Alright, in this last section of the chapter, we're going to be learning about function notation. Function notation is like another language. We're going to use function notation to solve for things and to graph with as well. So in the past, we're used to this language here. Y equals mx plus b. Function notation looks like this. You're going to have a letter. I'm going to use f. F of x equals mx plus b. This is function notation. I'm going to write that above there. Here's the old way, there's the new way. Notice some differences and some similarities. Gone is the y, and instead we have f of x. And then on the right side we have the mx plus b. That means the same thing. The slope is the m and the b is the y-intercept. F of x, whatever letter is here, g of x. That's how you say that beginning. It does not mean f times x. It's just a way to say it. Okay, here's our first problem. What is the value of the function f of x equals 2x plus 12 when x equals a negative 8? Again, this is a new language, so look at how I write this. It's telling us that x equals negative 8, so that's what I'm plugging in for x. But there are two x's here. F of negative 8 equals 2 times negative 8 plus 12. What's cool about function notation is you can show what number you're putting into the equation. This says that I'm putting negative 8 into this equation and I'm solving. So f of negative 8, I'm using order of operations. 2 times negative 8 is a negative 16. And then again, our answer, the function of negative 8 equals, different sign difference, we subtract, we get negative 4. So our answer is negative 4. Notice I didn't do any math with this over here. It's just the language. It just represents what we're doing. We plug negative 8 into the function and we got negative 4. Okay, your turn. Go ahead and push pause and try this. What is the value of the function f of x equals 3x minus 15 when x equals a negative 3? Okay. Here's another problem. This one's going to look different than our last one. It says, for the function f of x equals negative 2x plus 4, find the value of x, so f of x equals 16. They're not asking us to plug in x into the equation anymore. It doesn't say x equals 16. I'm not going to plug 16 into x. That's not what it's asking. This f of x replaces y. This is like a y. It's saying, find x when y equals 16. Again, f of x is just another fancy way of writing y. So for the function f of x equals negative 2x plus 4, find the value of x when f of x equals 16. It's telling us the answer. The answer is 16. This whole answer is 16. So we want to solve for x. It's kind of the reverse of what we did up there. So our answer is 16. Our goal is to find x. So we're going to leave x on the right side. Two-step equation. I get x to equal negative 6. Okay. Your turn. For the function f of x equals 2x minus 10, find the value of x, so f of x equals 6. Again, this is your y value. You're plugging it in on this side, and you're solving for x. Okay, this next section is graphing. Our title is going to be compare graphs with the graph of f of x equals x. You know what, I'm just going to say compare graphs. We'll just do that easy title. So here are our directions. Graph the function g of x. It's not f of x this time, it's g of x. Graph the function g of x equals negative 2x. Then compare the graph of f of x equals x. So we have two functions, or two equations this time. I have a g of x equals a negative 2x. There is also a f of x equals x. I have a g function and an f function. You are going to graph this the same way we have normally. We learned how to graph 3 different ways. You can use a table, you can use intercepts, or you can use slope and y-intercept. I'm going to choose the fastest and use the slope and the y-intercept. So on this function right here, this equation, we have a slope of -2. There is no plus anything, so my y-intercept is 0. Okay, I'm going to graph that first because that's what it's asking me to do. I'm going to get my graph paper. It's going to be important that you use graph paper. Okay, so here's going to be my g function here. The y-intercept is 0. My slope is down 2 to the right 1. It's going to be important to graph as many as you can, many ordered pairs as you can. I'm going to do the opposite. Instead of down 2 to the right 1, I'm going to go up 2 to the left 1 as well. You're going to want to use a straight edge. So my function looks like that. So I did step 1. Graph the function g of x when it equals -2x. Now I'm doing the next sentence. Compare the graph with the graph of f of x equals x. So let's graph it first so we can compare the two functions. This slope is 1. Again, there's no y-intercept, so we're starting at 0. Turn this into a fraction. Up 1 to the right 1. I'm also going to do the opposite, down 1 to the left 1. Important that you use that straight edge. Okay. Now comes the part where you have to compare these two functions. Well, let's say something about their slopes first. To me, it looks like we have one positive slope and one negative slope. So the function of g has a negative slope, and the function f function has a positive slope. So I'm going to go ahead and write that. I'm going to say the graph of g, and make sure it's g here. Yep, the red line. Here's the red line. Graph of g has a negative slope. And the graph of f has a positive slope. Okay, so we can describe a graph by its slope. You can also describe a graph with its intercepts. These two functions intercept at the same place. They both intercept the y. They both have the y-intercept of 0. So that's what I'm going to say. Both lines intercept at 0. You can say functions. I'm going to say at the origin. I think that's a better way to describe it. Okay. Let's do another one of these together. When it says compare, you have to write sentences. So you were thinking that now. Yes, you're going to be writing sentences. Okay, here's the next one. Graph the function g of x equals x plus 2, and then compare the graph with the graph of f of x equals x. Okay, so here we go again. We're going to graph this one. G of x. My slope is 1. My y-intercept is 2. I'm going to graph that information first. I did step 1. My second step is to compare the graph with the graph of f of x equals x. My slope is 1 and my y-intercept is 0. So here's 0. Again, the slope is up 1 to the right 1. My graph as many as necessary. So I can see what's going on here. Looks like we have two parallel lines. We learned in the last lesson that if you have the same slope, you're going to get parallel lines. So you're going to describe, you're going to compare these two. We're going to compare the slopes and we're going to compare the intercepts. Okay, so we're going to say, because these two have the same slope, the two functions are parallel. Oh, I should be writing this in black. Because both lines have the same slope, maybe you want to put what the slope is. They are parallel. Okay, so we describe the slope. Now we're going to describe the y-intercepts. They do not have the same y-intercepts. The red line, which is the graph of G, has an intercept of 2, and the graph of F has an intercept of 0. So we're going to say the y-intercept of G is 2 more than the y-intercept of F. Taking this a step further, if you remember our translations, this is or our transformations, this is a translation. Your line is moving from one place to another. We're going to be talking about that later on in the year. Okay, now it's your turn. You're going to graph and you're going to compare, and you're going to write 2 sentences about it. If you've noticed in both of the problems,